So since I'm the last obstacle between you and the launch, I will be brief. So benchmarking memory allocators. Also, I was told that I could do my talk in French, or in English. So I took the middle ground. It's going to be in English with a shitty French accent. So benchmarking memory allocators. It is I, Julien Voisin. My bio is on my website, but it's not really relevant for its talk, so feel free to go there or ignore it. So story time. So at home, I'm running Alpine Linux. It's a lightweight Linux thingy, and it's using the muscle libc. Most Linux distributions are using the glibc or whatnot, but this one is using muscle. And the muscle libc has its own memory allocator. So memory allocator is a small piece of software, and when you need some memory, you can ask, hey, can I have 50 megs or something? It will give you memory, and then you can say, oh, I don't need this memory anymore, it will free it. Pretty useful, pretty convenient, pretty standard. And I was idling on IRC, and someone said that the old memory allocator from Muscle sucked, and the new one is way better. And I was curious, is it better in what way? Is it faster? Is it more secure, simple, better use of my CPU? I don't know, maybe better colors. This is how I ended up giving a talk, apparently. Someone said something on IRC, and here I am. And also I wanted to know, is it really the best one? Maybe there are better ones around. That would be really nice to know. So I started with the first thing, I thought it was easy. It was not, but this is still the easier thing to measure: performances. And since I'm a grown-up, I didn't reinvent the wheel. I went on Google, GitHub, whatnot, and somebody already did all the hard work. It's Dan, I cannot pronounce his family name, from Microsoft, and he published something called Mimalloc Bench, which was designed to benchmark Mimalloc, which is the allocator from Microsoft. I think it's used in Azure and a couple of other internal Microsoft things, but also in video games. So it must be quite good. Unfortunately, Mimalloc Bench is written in Bash, but it was okay-ish. It had a couple of benchmarks, mostly Mimalloc oriented and other allocators. So I just added more stuff there. Benchmark. How do you benchmark memory locators? So there is real life ones and real life-ish ones, like Redis, the key value database. A lot of websites are using those, so I think it's kind of relevant. GhostScript, which is remote code execution as a service that somehow managed to display PDF sometimes. There is Z3, the solver for Microsoft. Lean, which is a theorem prover. RocksDB, which is like Redis, but by Facebook, I think. I'm not sure. GCC compiling the Lua interpreter. Espresso is, I think, a logic gate optimization thingy. And Barnes is a end body problem solver something. So it's real life-ish. I'm sure you're not solving logic gate optimization problem on a daily basis, but it's close enough. Academic one, because every single person who is publishing a paper about the new allocator comes up with their own benchmark to show how great their allocator is. Orbit test, I think, is some patch Ruby thingy to show something. Why not? And interestingly, it's making use of GitHub Actions to run the whole test suite on Ubuntu, Fedora, Alpine, and OS X. Amusingly, some people reach out to me, say, hey, I've got amazing ideas for benchmarking. Let's compile Chromium. No, GitHub Action do not allow you to spend 12 hours compiling Chromium 2 times a day. So there are constraints. If you have ideas of benchmark, keep this in mind. Also, I won't compile LLVM twice. No. Allocators, you can read all of them. It's a list, it's boring, but I'm sure your favorite one is there. So there is the muscle one. There is the glibc one. There is the tcmalloc from Google. There is the tcmalloc that used to be from Google, but it's not from Google anymore. There is gemalloc by Firefox. There is some weird ones like Scudo from Android as well. If your favorite one is not there, let me know. I will be happy to try to integrate it. Results. What can we do with all those lists? Sad stuff. Allocators tend to be Linux specific. So if you're running OS X like all the cool kids are doing these days, you won't be able to run the whole test suite. And also if you're on Windows, just forget about it. Most allocators are glibc specific, using weird extension for no good reason. So they don't work on muscle, which is annoying. This is a conferenceware. So people are writing, apparently, allocators, submitting papers, presenting at conferences, and the thing just doesn't compile or just doesn't work. But hey, they got like the paper at Black Hat or whatnot. Don't do this. Some are too slow to be included in the CI. So the continuous integration is running, and I think it's 2 hours top, and some were too slow. Like when I was running on my workstation, I've got a crazy powerful station at work. I had to use a double log scale for some allocators because one log was unreadable. So some are really just too slow. And amusingly, some allocators don't care about performances. I opened some bugs and they were like, yes, we know, it sucks, it's alright. And some are crashing. Like you cannot run Redis, which is key value database, on some allocator. So this is pretty bad. Computer sucks. Side effect improvements. Because in the process of adding more and more allocators, I found some bugs and tried to get them fixed. So some crashes, some portability improvement, like don't use the weird glibc extensions, these kind of things. Shiny graph, as promised. So this is GoScript running on Mimalok, and the memory it takes. So you can see the first version was taking a lot of memory. Then they realized this, so it went down. They work on other things, and then some minor improvement again. And the last 2 bars that you can see are the V2 version. So they redid part of the code, and you can clearly see the improvement. So when you're reading the changelog, it says improvement, and you're not sure what's going on, you can just run the test suite, and it will produce graph like this. Or you can run all the allocators on a single test, for example. So Espresso. You can see on the left, the more security-oriented, on your left, the more security-oriented one, like Die Harder or the Malloc NG from Muscle, or Harden Malloc, whatnot. And on the other side, you can see the performance-oriented. So it's about trade-off. IsoAlloc that I really like, the time it takes to run some artificial benchmark using a paper. So you can see the first 2 releases was kind of then it went way better. Then the author added more features security-wise, so it took more time, and now it's going down, and hopefully the next version will go down even more. Amusingly, about the benchmark, it's really hard to do generic benchmarks. Like I'm using GoScript to read PDF, so I like to read them fast. But someone from Google reached out to me after I shared a presentation, and they were like, did you run benchmark at like Google scale? I was like, no, I don't have 1000 CPU at home, but like, if you want to sponsor this work, sure. So, yeah. And also that's why the GitHub repository doesn't feature graph, because then people would just take them and say, oh, this allocator is the very best. But no, you have to tailor the benchmark to your workloads. If you're processing, I don't know, machine learning, image processing, whatnot, it's not really comparable with like rendering PDFs or Redis or these kind of things. So grain of salt all the way. I was told to a security conference, so I will talk about security. This is hard. Like security is hard. Lists, again, I've got a lot of lists in my slides. So spatial and type safety. So when you allocate some memory, maybe your application is using a bit more and like will result in a buffer overflow or underflow, these kind of things. And also type safety, maybe you're manipulating an object and then the program manipulates it in a different way. And then you've got like arbitrary code execution or crashes kind of things. There are a lot of possible mitigations. Some are good, some are bad. I think the most interesting one are to have the metadata of your chunk. put somewhere else, not next to the chunk. So when there is some wiggling, like buffer overflow, an attacker cannot override the metadata and have powerful primitives. There is also the idea of separating different types of objects. Like if you're allocating some weird user, mostly control thingy, maybe you don't want to put it next to credentials, for example. So you can isolate them. And if there is some wiggling or some issues, an attacker cannot trivially override credentials, kind of things. The slide will be put online, so you will have time to read and make your own mind on this. Temporal safety. Here, the idea is that you're allocating maybe an object, and then you're freeing it, and then you're reusing it again. Called a use after free. So it is like some problems on a time scale instead of a spatial scale. So also various mitigations, quarantine, randomization, a lot of boxes to tick. Memory tagging, that's super hot in the moment. You can do it in software with fat pointers. So the idea is that a pointer carries some information about the lifetime or the type or these kind of things. Or you can do it in hardware with memory tagging, MTEs kind of things. Apple is doing it. This would warrant a talk on its own, so I'm not going to talk about it, but the idea is that the hardware helps you avoid this kind of memory corruption issues. And weird stuff, like people are coming with crazy idea. There is an allocator that never reuse a pointer, so it's only going forwards. It's working to mitigate use after free for low, short-running programs, but it's not really usable in productions. And people are coming with really crazy things, CPU pinning or giga cages for Safari, kind of things. Benchmarking security is surprisingly hard. Well, not really surprising, but really hard. It's not because you're ticking a lot of boxes that you've got a lot of security. You can implement all the mitigations there, and maybe you will end up with a shitty allocator. So it's about trade-off. Apple recently published something about their kernel allocator, and since it's tightly integrated with the system, it can do powerful things. For example, I think GR Security is also doing this with AutoSlab. So they have type knowledge. Instead of only having the knowledge of the size of the object you're allocating, they've got the type. So you can segregate by type. So you can allocate your credentials over there and your user thingy over there, instead of only doing it by size. Or you can make use of the compiler to give you more information instead of just having your external allocator bundled on your library. Also, if an attacker has arbitrary read and writes, most of the time you lost, except with hardware assistance like memory tagging. So also trade-off, what are you defending against? I wrote some benchmark about security, can you detect use after free, reliability, kind of things. And someone reached out to me and said, hey, my allocator doesn't detect use after free, but you cannot exploit them. So you have to be careful about detecting security issues and neutering them, making them unexploitable. Also, the security and performance function is roughly square. You can have some really easy mitigation that are really effective, and then you just ending up piling more and more and more for diminishing returns. So you have to be mindful about this. Also, the performance budget. People like to have their software go really fast, be really snappy, and not eat all your memory, apparently. So if your allocator is really slow, but you brag about it being super secure, nobody will use it except some weird paranoid people. So you have to spend your budget, your performance budget really wisely and make choices about this. Also, this is the mitigator. It's by Halvar Flake. It's I think it's the well-intentioned gator always raising the bar to make the attack harder, but it's not really efficient. So designing mitigation is really hard, and Halvard did not only this magnificent crocodile, but also some rules about how to design mitigations. It's have a design doc, compare against known exploits like this mitigations, break this exploit, and this exploit. Also reach out to your friend in neighborhood exploit writer about your mitigation to see if it's useful or not, kind of things. So security is hard. Who knew? Next step, So after this talk, what I will do right now after this talk, no, more seriously, I'm planning on adding more allocator. And if your favorite allocator is not there, reach out to me and I will help you to help me to help you. Ideas and suggestions welcome for benchmark, but except Chromium and LLVM. So small stuff that represent real life workloads. I think I will add some JavaScript engine, maybe, because people like JavaScript. Publish more graph and data, but with a lot of like salt and caveats. And I'm a security engineer, so like proper graph and things confuse and frighten me. So if you're into UX and performance and metrics and SRE, reach out to me and tell me what you're into. And something that I would really like is for people to reuse this instead of coming up with their own crazy benchmark, because I'm tired of people bragging about it with like their small thingy benchmark. And if you use it on like Firefox, it just crashes already. It would be amazing to have like when people design new allocators to publish the code and the benchmark, because computer science paper without code shouldn't be a thing, like it shouldn't exist. I need a conclusion, so here is one, but I really don't like it. Mimalok is great. It's used at scale by Microsoft and Azure, processing huge workloads. Heavy Rain, I think the game, like some games are using Mimalok as well. So it's great if you want performance or general purpose allocator. If you want security-ish, you can use HardenMalloc or IsoAlloc. They've got like a huge design document and everything. But usually the default allocator is good enough. Otherwise, it wouldn't be the default one. And most big software that are scary and talking to the network and stuff, they are using their own allocator. Like your web browser is using its own allocator, and also the threat model of your web browser is a bit weird. Firefox, Apache, Nginx, Python, Java, you name it. So they've got their own one. You can replace it, but you will likely murder the performances for a minor security gain. And that's pretty much it. So if you've got questions, I'd be happy to answer them. Otherwise, we can all go to lunch. You got one question. Tell me. Come here and tell me.
So you mentioned JavaScript engine, but with like GSC and V8 having like their own object and things like that, would it be a bit biased because they have a dedicated use?
Well, the idea is to have workloads, like real-life-ish workloads, instead of just allocating 100 times, then freeing 100 times. So to have various patterns and these kind of things to see how the allocator is behaving. The goal is not to benchmark browsers, but to have like complex patterns. So this is the shortest talk of the whole conference, I think. All right, lunchtime. Thank you very much.